Well, guys, this is question from summer 21, uh, 9709, variant 33. Question number 9. The quadrilateral ABC is a trapezium in which AB and DC are parallel. With respect to the origin O, the position vectors of A, B, and C are given by OA, OB, and OC, three position vectors given. Given that DC is equal to 3AB, find the position vector of D. So here you can draw a figure, and this figure is not to the scale, just for the understanding. DC is equal to 3AB. Okay, that this is AB, and the other is DC, which is 3 times of that. So you can draw just a rough sketch. We have DC here. The position vectors of A, B, and C are given. Uh, Using this condition, using the DC vector is equal to 3 times of AB vector, the position vector of point D is question mark. Position vector of point D means OD. So for this, first find AB because both A and B are given. AB vector we know is OB minus OA. OB is given I plus 3J plus K minus OA is minus I plus 2J plus 3K. Uh, yes, these two are parallel. I plus 3J plus K plus I minus 2J minus 3K. Simplify. 2I plus J and minus 2K. This is vector AB. Next, using the condition which is given that DC is equal to 3AB, as DC is equal to 3AB, DC can be written in terms of position vector OC minus OD is equal to 3 times of AB, which is through 2I plus J minus 2K. OC is given again. OC is 2I plus 2J minus 3K. 2I plus 2J minus 3K minus OD is question mark 6I plus 3J minus 6K. So 2I plus 2J minus 3K minus 6I minus 3J plus 6K, simple algebra, OD. So finally, OD is 2I minus 6J is minus 4I. Then next, like 2J minus 3K is minus J, and finally plus 3K. Answer. So this is the position vector of so second part is find the vector equation of the line AB. Find the vector equation of the line AB. So A and B points are there, and yes, also we have the vector AB. For this case, I can write OA again here, minus I, it was plus 2J plus 3K, and OB was I plus 3J plus K, and yes, there is in the above we have AB line. This line is question mark. Find the vector equation of the line. So we know that the vector equation of the line is R is equals to A plus T into B, where T is the parameter, A is the point position vector, and B is the direction vector. And in the above working, we already have the vector AB. Also, we have the vector AB, and this AB is A was equal to 2I plus J minus 2K. So this vector can be used as the direction vector because line is the line which is line AB is passing through A and B, and AB is the vector lying on that line. So is the direction vector of line through A and B. So finally answer is R is R. A is the point position vector. It can be any point. It can be A, it can be B. Okay, let us use minus I plus 2J plus 3K plus parameter T into B, which is the direction vector, already having the previous working, 2I plus J minus 2K. So this is the answer to this part. This is the vector equation of line. Third part, for 5 marks, find the distance between the parallel sides and hence find the area of the trapezium. Distance between the parallel sides, distance between the parallel sides. So the distance between the parallel sides is required. As the line is there, AB, and we have this equation, the second part B. So the distance between these two parallel sides, find the distance between the two parallel sides is the distance which I just marked it here. So say this is H, or this can be taken as the height between the two parallel sides, the trapezium. The distance you can find either, because we have the equation for the line AB. So either you find the distance of C from either you find the distance of C from the line AB, or the distance. So all the distances are equal because AB and DC are parallel. So this distance is H, this distance is again H. So all these are equal. So you find, and this equation is there. So find the distance of either C or D from the line AB, which we have in the second part. So, and we must have that procedure clear in the mind, that how to find the distance of the point from the line. So for the distance of the point from the line, I can draw this sketch again. Say this is the line which is given. This is the line AB. This line is given, and this line has the vector equation, the previous part. And the second, there is a point, say, take the point C here. Take the point C or the point D, any point you can take. This is the point C, and C, the position vector is given for C. This line is AB. The equation of AB is there. R is equal to, so I can write this equation in the above equation in the column vector form, minus 1, 2, 3, minus 1, 2, 3, plus T into 2, 1, and minus 2, which was the direction vector. So first we'll find the general point on the line AB. This is the equation of line AB, finding a general point. So R, you can write the parametric equations, minus 1 plus 2t, y is equals to 2 plus t, and z is equals to 3 minus 2t. So you can say that there is a general point on line AB, and this point AB is the general point. So general point is, I can label this point as P. P is equals to minus 1 plus 2t and 2 plus t and 3 minus 2t. This is the general point, and relative to this figure, it can be here, because I'm trying to find the distance. So say this point is P. And next, I'm looking for this distance, and the distance from the point of line you can find by following a procedure in which what we do, let's follow this procedure. Uh, as we have the general point on the line AB, you can find the vector CP. Next, find, keep in mind that this angle is 90 degrees. Distance means the perpendicular distance. And I can complete this figure in this way. Yes, this was the trapezium. And next, we have the general point. T is there in terms of T. And next, I'm finding, next find CP vector. So CP vector is, you know, OP minus OC. OP is the position vector of the general point, minus 1 plus 2t, and 2 plus t, and 3 minus 2t, minus OC, the position vector of the point C, and C point is given 2, 2, and minus 3. So you can simplify to get the column vector. So minus 1 plus 2t minus 2 is 2t minus, the first one is 2t minus 3, then 2 plus t minus 2 is just t here, and 3 minus 2t minus minus is plus, so we have finally 6 minus 2t. This is the vector CP. So CP vector is perpendicular to AB. So in the given situation, also we have CP is perpendicular to AB. If the two vectors are perpendicular, then their scalar product is 0. So I'm looking for the distance. The distance means the length of C from the line. So this would be the distance. CP dot AB is equals to 0. CP vector, we just obtained 2t minus 3 and t minus just t and 6 minus 2t dot AB vector. We already have AB in the first part, the vector AB. That vector AB in the first part, let me verify, this vector AB was here. So you can write it as 2, 1, and minus 2. So 2, 1, and minus 2. Is equals to 0. So multiply the corresponding entries and add scalar product of the two vectors. Multiply, multiply, and add, multiply. This is the scalar product. Next is 2 into 2t minus 3 plus 1 into t plus minus 2 into 6 minus 2t is equals to 0, and 4t minus 6 plus t, then minus 12 plus 4t is equals to 0. 4 and 4, 8, and 90. 90 minus 18 is equals to 0. And yes, t is equals to 3 is the value of t for which the point P is there on the line AB, which is closest to C. So this, using this point, this value of t, you can find the vector CP. Therefore, CB vector is 2t minus 3, t, and 6 minus 2t. 3 to the 6 minus 3, this is coming as 3 to the 6. Sorry. This is not 3, but 2. So minus 4, 1, and 2, and 6 minus 4 is again 2. So after finding this CB vector, this vector is there, this vector is there, and keep in mind that this vector, the magnitude of this vector would be the magnitude of this vector would be the height between the two parallel sides of the trapezium. So magnitude of CP is 1 square plus 2 square plus 2 square, which is equal to 1 plus 4 plus 4, which is equal to 3, which is the height, which is the distance between the two parallel sides. This is the distance between parallel sides of the trapezium. So this is 3, this is 3, so we have 3, the distance between the two parallels. Next, the formula for the area of the trapezium is the half into sum of parallel sides. So parallel sides, the parallel sides are AB and DC. So as AB we have in the first part, you can find the magnitude of AB. What is the magnitude of AB? The magnitude of AB, the AB vector was 2I plus j. So AB vector was 2I plus j minus 2k. So its magnitude is 4 plus, I can show the working here. This is basically 2, 1, and minus 2. 2 square, 1 square, minus 2 square. This is again equals to 3. This is equals to 3. So 3 is, so AB length is equals to 3, and as DC is 3 times of AB, therefore I can say that the DC length is 3 times of 3, which is equals to 9. So we have the length A, so this length is coming as 3. This was 3 times of that, and the height is given between the two parallel sides. So finally, I can write the answer that the area of, find the area of the trapezium is equals to half into sum of parallel sides. Yes, these are the parallel sides. 3 plus 9 into the height, into the distance between the parallel sides, again 3. So answer is 1 over 2, 12, 3. This goes with it how many times? 6 times. So the answer is 18 units square. So this part was there for 5 marks. So just look at, so equation of AB was there in the previous part. So the distance between, so the important, so there was no issue with the lengths of the two parallel sides, because AB vector is there. You can find the length AB, and 3 times of that is the length of DC. So the length of the parallel sides are given. So the main issue was what is the distance between the two parallel sides, and for this we follow the procedure in which we apply the concept of the distance of the point from the line. So you can choose any one of the 2 points. I chose the point C, and then I found the distance of this point C from the line, and this line was the equation AB. This was the equation AB, equation of the line AB. And yes, you can find the general point on this line, and this general point is here, the point P. And then I found the vector CP. You can take the general point on this side as well. So, but I chose on that side because the distance of C from P I wanted to calculate. So I followed the procedure in which I obtained the vector CP. Then I use the fact that the distance for the distance CP must be perpendicular to the AB. The angle is 90 degrees between them. So I use the scalar product, and finally the parameter equation. The parameter was there too, and using this parameter, I can find the vector CP, and the magnitude of CP would be the distance between the parallel sides, and find the lengths of the parallel sides and apply the formula for the area of the trapezium. Thank you.